My name's Charlie Gordon and I work for Britest. We provide technical facilitation expertise to support the capture of knowledge and process insight for the design, scale-up and implementation of innovative processes and process technologies. Along with several colleagues, I've been developing digital information flow frameworks for pharmaceutical product and process design. These will be needed to ensure that the modelling tools being developed in the ADDoPT project can be applied effectively to improve and potentially replace the current experimentally based development approaches used in the pharmaceutical sector. We've developed these information flows by interviewing experts from across the ADDoPT network. We've gathered input from the industrial partners to understand the information required to move from the definition of an API molecule to the design of a full-scale pharmaceutical manufacturing process. Other partners have provided us with information on their existing and emerging approaches that can be used to predict the properties and behaviour of molecules, particles and mixtures. And finally, the system integrators at PSE and Perceptive Engineering have helped us to build the end-to-end information flows, incorporating their future vision of digital process design and control. The exciting opportunity of digital design is to be able to predict the impact of changes in particle properties on performance, stability and manufacturability of a pharmaceutical product. The ability to map a wide range of what-if scenarios has the potential to significantly reduce the number of experiments required to develop pharmaceutical products, reducing the high-value material requirements and low-value experimental work. The ADDoPT information flows ensure that the opportunities offered by digital design are clearly mapped onto the industry's development workflows. They allow industry end users to understand the current and future state of models, including the data requirements and the level of information fidelity required. Ultimately, we could envisage a model where the only experimental work needed is a validation step to confirm the output of the models. The benefits we see are significantly reduced timelines and costs for process development activities, combined with more robust manufacturing scale-up and more assured product performance and stability. From the outset, we have aimed to develop the digital information flow in an interactive, explorable format, and we're now working to integrate this into ADDoPT's primary dissemination resource, the ADDoPT Online Digital Design Guide. This will provide an easily accessible resource for people working in pharmaceutical development to help them understand how digital design can deliver faster, more effective development of pharmaceutical products. The Digital Design Guide is intended to provide different levels of information, depending on the level of expertise and interest of the person using it, whether they be a new researcher who wants to increase their skill set, or a senior manager who needs to understand how digital design can increase the overall efficiency of their organisation.